Hello, good morning, everybody. You're very welcome to the DLR Home Energy Upgrade webinar this morning. There's still people joining us, but we decided we'd start on time. I know some of you have been waiting a few minutes to come in. So this event is brought to you by the DLR Energy team, who've recently been shortlisted for Energy Team of the Year awards in the Sustainable Energy Authority of Ireland awards. So that's going to be announced next week. And then it's also part of the Open House Dublin Architecture Festival, and it's been facilitated by Codema on the technical end. So and we have a great lineup of panelists for you. I'll just speak first a little bit about Dunnera-Rathdown County Council and what we're doing in relation to carbon and energy. And then I'll introduce you to each of the panelists and have some questions. So firstly, in this county in particular, 64% of our carbon emissions are related to buildings, and 43.5% are from private residential homes, 18.5% from commercial buildings, about 1.2% from council-owned housing, and about 1% from DLR buildings. So, you know, what this tells us is that we need collaboration, I suppose, as a community and from all citizens really, and business owners to engage with this process. What we're endeavouring to do is set a high standard for low carbon buildings and development, so that we're future proofing for the county and getting as close to zero carbon as possible for the 2050 targets. Dunnera-Rathdown in itself, in terms of the energy we use, a large portion, nearly half, is from public lighting, about 18% or so from fleet, and then the rest from buildings. So over all those categories, we've reduced our energy by 51% since 2009, and the target was 33%, so we achieved that and exceeded that target, and we've reduced carbon about 44%. So yeah, we're doing what we can, but this is really, I suppose, an opportunity for people maybe who own their own homes and who are thinking about doing renovations or upgrades or extensions to go, well, actually, can I incorporate some carbon reduction measures within that and improve efficiency and reduce my bills? So the format that we'll take is that I'll introduce you to each of the speakers, and after the first two speakers, we'll have a Q&A at that stage. And then we'll have a further 4 speakers and a further Q&A after that. So if you've got a question, you can type it into the Q&A box, which is at the bottom of your screen. And if you can also mention who the question is addressed to. And then of everybody participating today, we will have one winner of a €50 one-for-all voucher. So what we'll do is we'll keep a track of everybody who's joined and then randomly pick that, and we'll announce it on social media. So thanks again. So first up is Susan Andrews from Sustainable Energy Authority of Ireland, who are the main government agency working in this area. She's a programme manager and works with householders, businesses, communities and government to create a cleaner energy future. She's recently completed a BER assessment training, and this complements her Master's of Science and Bachelor of Science from Trinity, and she has over 20 years of business and marketing experience across a wide range of sectors. So I know certainly since all the new changes and the budget and climate action, everything else, there's a lot of interest in this area. So we'll start with Susan then, and yeah, we'll take it from there. Thanks.
Thank you, Evelyn. Thanks very much. I hope everybody can see my screen there. And just put it in presenter mode. Okay, so thanks very much, Evelyn. As Evelyn said, I work with the SEAI. So for those of you who aren't familiar, we are the Sustainable Energy Authority of Ireland, and we're a government agency. So we work with government, homeowners, businesses and communities, and it's all about helping them move towards a cleaner energy future. So our role, as I said, it's helping Ireland as a nation move towards a low carbon energy future. And to do that, we need to source sustainable, secure, affordable and clean energy. And it's really all about making people aware that they need to be using less energy and clean energy. And to do that, we're going to have to find more innovative ways of meeting our energy demands. So the SEAI is leading that transition towards smarter and sustainable energy activities. In particular, we're supporting the government's Climate Action Plan, which is to significantly reduce Ireland's greenhouse gas emissions by 2030. And looking at the impact of housing in particular, we need to upgrade 500,000 homes to a minimum B2 BER rating by 2030. We need to install 600,000 heat pumps, and 400,000 of those need to be installed into existing homes. And just to put that in context, 50% of houses in Ireland have a BER rating of D or lower. So they're very carbon intensive and are going to require significant energy upgrades to meet these targets. So to date, the SEAI has supported over 450,000 homes in their home energy upgrade journey. So home energy upgrade, what is it? Well, it's all about making your home more energy efficient, and it's also going to give you a whole new world of comfort. So if we look at homes, and just an important statistic to note is that houses account for a quarter of all energy consumption in Ireland. So in particular, in one house where you've uninsulated attics and walls and underperforming doors and windows, your heating is accounting for 80% of your home energy. So you're losing, if you have an uninsulated home, you're losing up to 30% of your valuable heat through those uninsulated roofs and walls, and a further 10 to 20% through uninsulated floors and underperforming doors and windows. So you're probably asking, well, why do I want to do a home energy upgrade? What's in it for me? Well, the number one factor is comfort. So, by insulating your home, you're going to make it much warmer and cozier, and you're going to have a healthier living environment. Also, then you're adding renewables, you're going to cleaner, more sustainable energy, and all of this is going to have a really positive impact on your pockets. So by really well insulating your home, you're not going to have your heat on as often. So you're reducing your energy bills. And as well as that, you're having a positive impact on the environment because you're reducing your home's carbon footprint. And all of this, like with any home upgrade, is going to add value to your home. So even in terms of an energy upgrade, you're improving your BER rating, and that's going to increase the value of your home. So we're often asked by homeowners who really don't know where to start, they don't know what to do, what are the steps to a home energy upgrade? And what we would say is, first of all, if you really don't know where to start with an assessment. Then it's insulation. And then the third step is adding renewables. And I'll just go through those in a bit more detail. So assessment, as I said, if you don't know where to start, but you have a cold home, it's uninsulated and you want to do something about it, well, get a BER assessment done on your home. And this is the best way for you to find out how your home is performing in terms of energy efficiency and what you can do to improve it. So after the assessment, and it's a non-intrusive assessment, you're going to get a personalized advisory report. And that's going to help you understand the types of energy upgrades that are best suited for your home, and also the available grants that are going to help you along your home energy upgrade journey. And it's going to provide you with a roadmap to achieving a minimum B2 BER rating. So we have a list of BER assessors on our website. And what we'd always say is, the assessment costs between 200 to 250 euro, but do shop around and get quotes and make sure you're happy with the assessor you choose. So the next step then, which is really important, it's all about insulating your home and keeping that valuable heat in. And as I said, you can lose up to 30% of your heat through a poorly insulated attic space and walls. You may also need to look at your windows and doors. If they're old or single glazed, they may need to be replaced, and that in turn is going to help improve your insulation. So by properly insulating your home, you're really going to improve the comfort levels. So we often hear homeowners that have gone through this home energy upgrade where previously they had rooms that they couldn't use, just they were too cold, uncomfortable. They get the sense that they have a bigger home because they can use every room and it's nice and warm. And as I said, you're also then reducing your heating bills because you don't need to have your heat on as long because it's holding it in the house, and you're reducing your carbon footprint. And the SEAI offers various insulation grants ranging from 400 euro for the likes of attic and cavity wall insulation up to the likes of 6,000 euro for external wall insulation. And there's a full list of that on our website. So when you do have a really well insulated home, then you need to consider adding renewable technologies. So renewable technologies are going to again reduce your energy bills further and improve the BER rating of your home. And it's also supporting that move away from fossil fuels. So you're reducing your home's carbon footprint. So one of the popular ones that I'm sure you've heard of now are heat pump systems. So they're a really good alternative to fossil fuel oil and gas boilers, and they're highly efficient. And then you can also look at solar PV for generating your own electricity, and that's going to reduce your bills roughly between 200 to 300 euro per year. Obviously, it depends on your energy use, the number of people in the house, the size of the house, so that's an approximation. And then solar thermal for hot water, again, it's designed to meet about 50 to 60% of your overall hot water demand. So all the time, it's reducing your energy bills, moving you towards cleaner energy sources, and again, increasing the value of your house and improving your BER rating. So the SEAI offers various routes to getting a home energy upgrade grant. So this is to suit homeowners' different needs and requirements. So we do have a free energy upgrade route, and that's for qualifying homeowners that are in receipt of certain welfare payments. Now, there's a list on our website, but it includes the likes of the fuel allowance, domiciliary care allowance, the carers allowance. So do have a look and see if you qualify for that. As I said, it's fully funded by the SEAI, and we manage that entire service. So what we do is we'll send out somebody to do a home survey, and they'll determine what energy upgrades are required in the home. And we always look at insulation first. So it will be looking at your attic space, your walls, and to see what insulation is required. Case by case, we do look at windows and heating systems, and if we see that there's single glazed windows or there's no heating system, that will be addressed, but it is very much case by case. We assign the contractor to carry out the works, and then we do a follow-up BER. So doing the post-works BER is important to make sure that the grants are achieving their purpose and that they're improving the energy rating of the homes. Now, if you don't qualify under that route, then we have two other routes. So we have what's called the OneStop Shop service. So this is a complete home energy upgrade solution. So if you actually want to do multiple energy upgrades in one go, it's usually fairly daunting and homeowners like a bit of support, this is probably the option for you. It's part funded by SEAI, so it covers roughly a third of the cost of works. And the one-stop shop will fully manage the entire project from start to finish, and that includes the grant application. So a requirement here is that your home must get to a minimum B2. So your one-stop shop will advise you of what energy upgrades you need to carry out to get your home to a B2. And the benefit here for the homeowner is that they will pay for the works minus the grant, and then the one-stop shop claims the grant back after the works have been completed. So it takes all the pain and the hassle out of the process, and it helps you get it all done in one go. Now, if you're not in that position, or you might just want to do one or two energy upgrades, then you can look at our individual energy upgrade grants, and that's where we have a range of upgrades. So the likes of attic insulation, we've various types of wall insulation grants, and again, we address heating systems, and we have renewable grants. These are again part funded by SEAI, so similar to the one-stop shop, they cover a third of the cost. In this case, the homeowner manages the upgrade project, so they need to ensure that they have their grant application in place before they start works. That's very important. We have an online application wizard, so it's very easy to get the grant approval in place. And then you have to choose your registered contractor. So we've a list of both one-stop shops and individual registered contractors to support both of these routes. And the contractor carries out the works. You have 8 months to get all the works completed, fill in your paperwork, send it back to us. And once the works are completed, you then claim the grant. So that's the difference. So it's really to have those three different routes there to support homeowners depending on their budgets, their situation, and what they want to achieve. So under the three routes, this just gives you an idea of the various energy upgrades that are available. If I look at the one-stop shop service first, you'll see that it's the full range. Now you can choose what you want, but just to say you do need to meet the B2 requirements. So the one-stop shop will carry out a home energy assessment, and that will include a pre-BER and a further assessment to give you a full plan on what's required to meet that B2. It looks after project management, and then it looks after the full range of insulation, whether you want to go the heat pump system and add your renewables. And then ventilation is key as you get to a higher BER to make sure you've got good, healthy ventilation going through the house. So the one-stop shop service covers the whole lot. Free energy upgrades, again, we do a home energy assessment. It's not a BER, it's a home survey to see what upgrades are required. And then it fundamentally looks at insulation, number one, and then, as I said, it'll address certain things like windows and heating systems on a case by case. And then you have a smaller range of individual energy upgrades, and again, it's covering your insulation, your attic, your wall insulation. Then you can choose from whether you want to improve your existing boiler by adding heating controls, or if you want to go down, excuse me, the renewable technology, you can add your heat pump or your solar thermal and your solar PV. So to date, we've had over 450,000 home owners, as I said, go through the home energy upgrade journey with grants from SEAI. And it is really all about making your home comfortable, cozier, reducing those energy bills, increasing the value of your home, and naturally, you're going to be improving your carbon footprint. So I just finish off by saying there's a lot of information there. We've actually got a new landing page on our website. So it's seai.ie/home energy upgrades. And it's a huge amount of information to guide you through your home energy upgrade journey and to go through the details of the different grant routes available to you, with links to the various one-stop shops and the registered contractors. And plus we have a team there. So if you have any questions, give them a call and they can talk them through it. Okay.
Okay, thanks, Susan. That's great. A really good overview of that range of supports and kind of who can apply for in what area depending on their circumstances. So our next presenter is Mel Reynolds, and he's a registered architect with over 30 years of experience in Ireland, the UK and the US in project management, conservation, urban design and developer-led housing. So Mel has a degree in architecture, a master's in urban and building conservation, a diploma in project management, and is a certified passive house designer. He established his own practice in 2008, and he also lectured on property development, procurement, and professional practice. So next up is Mel. Thanks.
Thank you, Evan. Thanks a lot. Well done to anyone who's tuning in here. It's early on a Sunday morning, so I'm not going to bombard you with too many facts and figures. I'm going to show you some nice pictures of what is possible to do on a case study, and then also show, I suppose, really talk you through the sort of thought process involved in doing low energy building, doing the sort of third version of what Susan was saying there, where you're looking at a larger project and trying to manage the process yourself. I think a later speaker, Mike ORourke, is going to be talking about the Superhomes OneStop Shop, which is a brilliant service. I think certainly what I've done, where I have clients coming to me looking only to upgrade their fabric, I would have referred them on to the Superhomes team. They're brilliant, they're really good. Because I suppose really the issue with retrofits is that retrofits are complicated, you know, and each building is slightly different. So there's no one size fits all. There is a certain amount of work and homework required by homeowners to get the best they can out of each project. But if, as Susan said, if you can plan in advance, give yourself as much information as possible with regards to making your informed decisions as you go along. So if we just go to the second slide there, Phelim, thank you very much. Just the headline subjects we'll be talking about here, you're probably going to hear a lot of people coming up with the same, what we're seeing is convergence, is the approach is pretty much common in a number of different jurisdictions to low energy building and upgrades. Planning is very important at the outset. Assess what you have, plan for what, and see what gives you a bit of bang for your buck as well as you go along. There's a number of different headings here as well we go through in terms of water and landscape. The case study I'll be looking at is a project I did. We completed it almost 2 years ago, Cove Mews, which is a modest sized, it's about 120 square metre, 3 to 5 bed house. And initially it was a project done by myself. I looked at it as almost like a prototype dwelling to see how far we could get on a tight urban site down this route in terms of sustainability and low energy. And the remarkable thing was you can get a long distance down without any extra cost using proven technologies and without any compromise in your aesthetics. So just out of interest there, on that first slide, you can see Rochestown House. That was a project done by DLR. retrofit project. It was done to the passive standard, actually, I think back in 2016, 2017. And I think if the numbers are correct, they started out with a really poor existing building. The condition was very bad. I think there was about 32 dwellings in it, primarily single units. After the retrofit, these units were passive standard. They added an extra floor, and I think they ended up with 32 two-bed homes. And I think the cost was about €95,000 per dwelling. So even when you're looking at almost a semi-derelict existing building, you can get to these really, really high standards for relatively cost efficiently. The second project there just below it is a very sort of ordinary looking 3-bed semi-D. That's a project Madeira Oaks in Wexford. And that was the first sort of mainstream residential project that was built, I think again in around 2016, 2017. It was a certified passive standard estate of homes that looked like normal houses, but their total energy bills for the year were a fraction of what you'd normally have. And I think the first phase of these houses were sold for €172,000. So this was the first real confirmation in Ireland that, to go with the extra mile on energy efficiency would not cost you anything extra. And the thing that attracted me to Madeira Oaks was the simplicity of it, in that there's no primary heating system. You effectively had one unit that did your heating and hot water. And the house was so efficient that the space heating bills were almost negligible for the entire year. So if we just go on to the next slide there, and we'll get stuck into I suppose broadly speaking, in terms of retrofit projects, the supports from the SEAI are excellent. The initiative, the OneStop Shop initiative, is very, very good. When you're coming to manage a project yourself, it gets trickier because you have to negotiate the grants, you have tendering and procurement, getting the right contractors. How do you do it? And I would suggest that, the passive standard, that image there is the passive standard. It's 30 years old. So basically, we have a standard here that's been operating at this really, really low energy level and helping design buildings for 30 years. It's been audited, measured, double checked. There's no performance gap. And now the suite of design aids that you have here for your design team are absolutely brilliant. When you model this, the modeling that's done for the passive house system is very, very exact and very rigorous. And I think the modeling is probably more interesting. To actually use the modeling that they have and use the systems they have is a massive benefit to any design team or anyone doing a project. Even if you're not going for the standard, it doesn't matter. But if it says you're going to use a certain amount of energy after doing X, Y, and Z, there's no performance gap at all. So I think for larger projects, I would absolutely get your passive house modeling done. And if you have your own design team, your own architect, engineers, quantity surveyors, etc., doing your project, to get a passive house consultant involved is probably less than 1% of your construction costs. So it's negligible here, but it's a brilliant aid to tell you exactly how this is going to work. And the difficulty we have is that the insulation goes hand in hand with ventilation. So once you get to a certain point of insulation, you have to look very, very carefully at your ventilation to make sure that you're getting your air changes per hour. You're not creating problems in terms of mold growth or overheating later on. And this is where the passive sort of design tool is brilliant. Next slide there, please, Phelan. So I suppose this is the only sort of set of plans I'll be showing you. So just bear with me on it. On the left are the plans of Cove Mews. It was 1,200 square foot house, 120 square meters roughly, on a very tight site, about 135 square meters. So that's the equivalent of about 8 car parking spaces, an urban site. On the right-hand side is your typical 4-bed semi-D. So at every stage, before we started in the planning stage, we looked at the scope to see, is it too big? Can I get more? How can I make this more efficient? So the color-coded colors there represent your internal space, your internal circulation space, and utility rooms, undercroft, understairs, etc., and toilets. So I think if you're in any project you're looking at, don't be caught on how big is your house. Is it 1,500 square foot? Is it 2,000? You should be looking at your net usable space. And frequently people extend and build and create dead space. So you should be trying to build less, physically build less, and get more out of it. And I think Pat Barry from the Green Building Council is a really good stat that, you know, if we just right-sized our new homes at the moment to appropriate sizes and not overbuilt, overscaled homes, we would save about 300,000 tons of CO2 a year, something like that. It's massive. So irrespective of your upgrades or your standards, get your scope down. And in this project, because I had an eye on scaling it up and making it a prototype, is the site area used. You can see the physical site here is over a third less than the minimum size needed for 4-bed semi-D. The gross floor space here is the same. It's about 120 square meters, but I'm actually getting more usable space out of the internal spaces. So I'm getting the equivalent of 10% extra usable space out of this because we put the living rooms over the bedrooms down below. So on this one, no front garden. You park in your building under your living room. I've got a garden over on the roof of the bedroom. So from a development perspective, I'm getting 30% extra density, but also from a space perspective, this is the equivalent of about 1,500 square foot. And was anyone who went into the house was amazed at how spacious it was. And that's because you can measure it. So it's really important, particularly for extensions, or make sure your scope is right. Don't build the biggest thing you want. Build the most efficient thing you can on your site. Next slide there, please, Phelan, thanks. So I think there's a couple of headings that people normally look at. This is a view from the upper floor roof terrace, which faces south. You can see we have a very large south-facing glazing glaze screen there. So the main garden space on this was upstairs in this enclosed courtyard. There's effectively no the ground floor courtyard bedrooms look into it, and there's a car parking space, and the upstairs amenity space is upstairs here. The benefit of this, I suppose, is that the glazing, one other aspect in terms of design was I was very keen to see how far we could go on a really tight urban site. So there's no compromise really on aesthetics, on, you know, the renewables here are almost invisible as well. One of the key questions you want to look at is, you know, what's my payback for doing A, B, or C? Really, the question you should be asking is, what are the opportunities if you're doing a large scale upgrade? You should be aiming for an A rating because it's no extra cost. So there are certain things like air tightness, making your building more insulated, but air tightness is critical. That's really difficult to do later on. So for example, on this one, we put in rainwater harvesting because we physically couldn't put in the tank. It was so big later on. There was no space for it. So there's some things that would be very expensive for you to do later on that may not make a huge amount of sense at this stage, but it's the cost to retrofit those later. And next slide there, please. So in terms of your insulation, once you're aiming for an A rating on your retrofit, your ventilation and your insulation go hand in hand. So you need to model the two. And I just put up these two slides here. This one is of the living room upstairs, which is an open plan living room, and the other one is of a typical bedroom. And this is almost like spot the bulb, where you'd want to see where is your heating system. So in a normal room, you see your radiators, underfloor system, you might see a stat on the wall. On this one, it's an airborne centralized ventilation system. So the extract is a small little circle over where the hob and cooker is in the kitchen. And then on the bottom left of there you go, on the bottom left of the slide there, under the table, there is the air intake for the living room. And then you have your air supply to your bedrooms right where the little hand, Phelan's put the little hand there as well. So the space heating is very, very, very low level. You don't need a huge amount of it. But what you do, the air quality is absolutely brilliant. Now, one of the things a lot of people will say is, oh, well, for passive houses, you can't open the windows and doors. That's absolute rubbish. You operate your house as normal. In winter, you're looking at, you know, bedroom temperatures of 18 degrees and living room temperatures of 21 degrees all day, 24 hours a day, and the air quality is filtered. It's absolutely amazing. So living in this, the one big revelation to me moving from a standard house was the indoor air quality was extraordinary. It was like living in Dublin, moving down the country on your holiday, and for the first couple of nights you're knocked out at the amount of fresh air you get. It's incredible. So you're looking at really, really low levels of heat required for an airborne system like this. And again, there's no boiler. So the critical thing in this project was, by using the passive modeling, I knew at an early stage we didn't need a boiler or underfloor heating in this. So that saved us about 13 or 14,000 euros. We spent about 6 extra on our glazing to get it better, a much higher standard of glazing than normally we'd use on an A-rated house. And then we put the balance, about 6,000 to 7,000 euros of PV on the roof, towards the extra overcost for a large PV array. So in terms of build costs, I think that it's actually cheaper to build to the standard. And this is a 2030, 2040 standard. We don't have a standard like this yet in Ireland, but we're moving towards it. Next slide there, please. So then the other aspects you want to look at is sort of, your appliances, your plug-in loads. I know that Katie will be talking about this a little bit later on, but we did a full demand control model on this, looking at appliance loads, when we would be using them, your energy, total energy use, hot water, etc. So, AAA rated appliances, low flow fittings are very important. We put in rainwater harvesting because there's a chance this will come back in, we'll get water charges later on, and 30% of your treated water is being used to flush toilets. It makes no sense whatsoever. So we do have rainwater harvesting here for toilets. We also have, there was no space for a garden. So what we did was we put in a living wall here. The top slide, you can see it. Plants were chosen for biodiversity, for bees, and there are bats nearby as well. So I didn't tell my wife that at the time, but we have, and we've strawberry plants in there as well. So that's it's not only is it a feature, but it's sort of a functional feature as well in the whole project. You can do more. So, I mean, there were opportunities I left behind in this in terms of embodied carbon. Pat will talk about that later on. But also you can do grey water harvesting, which is using sink water to flush your toilets. And then you can use your rainwater harvesting for other things. But you can also do wastewater heat recovery, which is where your hot water from your showers doesn't mix, but preheats cold water coming in. And that can reduce your hot water again by 30%. Next slide there, please. So in terms of renewables, as was said earlier, your first port of call is energy efficiency and insulating and ventilating correctly. Then you look at renewables because you really want to get the bang for your buck from that. So in this project, we had, luckily I had a neighbour of mine, was Tim Cooper, has been involved in renewables for many years. He did the green building in Temple Bar 26 years ago. And this really fit in with his research at the time. So he volunteered to do a demand control model on the project. We looked at one of the critical things I wanted to do here was be the first in the UK and Ireland to hit is a higher level than passive standard, is passive plus, which involved putting about 6 kilowatts of renewables on the project. So one of the challenges there was how to fit all these solar panels without the house looking like a space station. So as you can see from this photo, they're all very discreet, hidden on a flat roof, facing east-west, and they produce about 6.8 kilowatts a year. The difficulty with renewables is, I mean, if you can get your energy efficiency down, you're really getting a bang for your buck from it. The second biggest load you'll have in your house is hot water. So we did an awful lot of modeling on this. We looked at it, the cost of the house without PV, the total energy cost, including your plug-in loads, was about 1,700 euros a year, which is very low. When you put your PV on the roof, it dropped to about 1,000 euros. And then by looking at actual usage, daily usage, storage, seasonal differences, etc., using hot water as a battery, effectively using your hot water tanks as a way to harvest renewable energy, we got our total energy cost for not just for heat and hot water, but for plug-in loads down to around 300 euros per annum. So that includes your cooking, TVs, lights, the lot. So that would exclude your standing charge and your PSO levy. But we still lost energy to the grid because you've seasoned it. Some days you're producing energy, you can't store it, you're losing it to the grid, etc. So the real interesting thing here is when you plug an EV into this house for 2 hours a day, 5 days a week, you can get about 10,000 kilometers from your roof. So instead of paying 900 euros for a petrol or diesel car for 15,000 kilometers, your grid cost for your 15,000 kilometers is about 93 euros. So you get this doubling effect. So it's very, very significant. So in terms of your transport emissions and your house emissions, by aiming for this really low energy standard and then packing as much renewable technology as you can into it and plugging your car in, all of a sudden you're looking at an 80% drop in carbon emissions for a typical A2 house and a diesel car versus this model. So, I mean, the interesting thing at the time is we looked at, in September, we measured this and we were off grid every second day. And I think our total energy bill, now at the time we were selling the house, so we weren't cooking, but we were doing everything else in the house for the month. Lights on all night for security. We had TV on, we had our car plugged in. We used the grid once to fill the car. And our total energy bills for September were €13.60. So the standing charge for the ESB was higher, was €40. So these are the sort of levels, it's almost unbelievable sort of levels you can get to. Next slide there, please. So if you want to go, I think a larger scale retrofit is an opportunity to go further, to hit the A level. If you use something like the passive standard, they've been doing this for years, you've no performance gap, you get the quality control of the standard, and it's an absolutely brilliant design tool. It allows you to alter your specification and see, do I need this, do I need that, what happens when I change a different material. Next slide there, please. So just two examples of retrofits. So these are the last two slides. We have an A1 refurbishment, that's to the Enerfit standard on the top slide. That was a 1930 semi-D that we finished about a year ago. It has unbelievable energy performance in it and air quality. It was a 2-story gable extension, single story to the rear. The extra over cost to get this to the A1 standard was €4,000. That's it. And the one down below is one we're doing at the moment, is going to be Enerfit. That's a mid-terrace red brick exempted development. Next slide there, please. Which will show you, these are some of the progress slides I took on Friday of it actually, where you can see we're using a decentralized mechanical system to ventilate the house, which are like, you know, little standalone vents, your heat pump out the back. That's a little snapshot of your external insulation. And we're getting this building airtight down to about 1.5 air changes an hour. So they don't need radiators upstairs. We just have underfloor downstairs and that's it. And it's going to be a 3-story. We've converted the attic was converted already. So I suppose that's it. I mean, you know, if you are, the one-stop shop is the way I would go if you're looking at energy retrofits, purely for that. If you're doing a larger job, you have an opportunity to get to the A standard using these established methods and skills that are out there very easily at negligible extra cost. And I would urge everyone not to lose the opportunity. If you're in a new house, if you're going to do a lot of work to it, new kitchen, new bathrooms, extend it, get to the A rate, and that's what you should be targeting. Thank you.
Great. Thanks, Mel. Now, we've had a lot of questions. Great to see everybody really interactive, and some of the questions have already been answered in the Q&A. And just to try and keep on track and everything, we might take just one question now and then see if we can come to more at the end that haven't been already answered, is that in terms of written answers. So there was a question in for either Susan or Mel in relation to older houses, Victorian house. I know you have that example there. So it was for insulation, heating and more sustainable energy power, like how do you insulate the walls and windows in such a case where there are architectural features such as cornices, original sash windows, and what heating systems are suitable, given that heat pumps are exchanged, which seem to be a runner in most older houses. So apart from just, you know, good attic insulation and chimney balloons. So either Susan or Mel, do you want to take that question? We'll just take the one at the moment, and then the next presenter will be Pat from the Irish Green Building Council.
Sure, I can take that if you like. The Victorian houses or protected structures are trickier, and the reason for that is you're limited to what you can do. You've got existing fabric, you've got existing sash windows, you also have moisture, and these buildings were designed to, you know, have a lot of air movement through them, and also to allow moisture in and out. So you just have to be really careful with them. I would suggest if you're going to do retrofits there are materials you can use, and there are certain heating systems you go for, but you just have to be really careful in terms of how you're insulating, what you're insulating, and in particular the moisture movement through it. So I would suggest that you need, that person probably needs to get a conservation architect to look in to see what's appropriate. And then secondly, to get the passive house modeling done on it, because the PHPP software that they use captures issues to do with mold growth, adequate ventilation, and also moisture movement through the structure. So you need to just be very careful. The less you do, the better. Older buildings are always light touch, but there are products out there on that particular red brick. And those 2 projects, we used one on the front wall of the house. We were able to do it because we had a brick front wall. Internally, it's going to be trickier because of cornicing and internal features. So you just have to walk very carefully, get a bit more detailed input on it. And, you may not be able to go as far as you want to, but I suppose the real overarching thing is do whatever you can. Like, for example, attic insulation. There's a really good Irish company called EcoCell do recycled newspaper cellulose insulation, which is a brilliant product. You know from the first slide that Susan did, 30% of your heat loss is through your attic. If you can put 300 mil of this product up in your attic, it allows moisture movement through it. It aids in terms of draft heat loss of your building as well, but it's really compatible with older fabrics. So you just need to be a bit more careful in that.
Sorry. Great. Thanks very much, Mel. So as I said, do keep your questions coming, and we'll try and answer them, as I said, in the chat box itself, and then also at the end. But as I said, this is kind of just a taster of a range of experts and architects, as I said, who are sharing their expertise. So as I said, yeah, we can't get into any kind of very specific details at this point. But our next speaker is Pat Barry from the Irish Green Building Council. So he's the Chief Executive and co-founder of it from 2010. He's an architect with over 20 years experience in Ireland, Europe and South America. He has a master's in environmental design of buildings from the University of Cardiff and qualified passive house and DGNB consultant, which is a German qualification for sustainable building systems. So over to you now, Pat. Thank you.
Thank you everybody for participating so early this morning. So just a word on who we are with the Irish Green Building Council. We are a non-profit membership organisation advocating for a sustainable built environment. I suppose we take a more broader view of sustainability than just the energy efficiency of buildings. We look at all of the impacts that buildings have on planet and on people. And it's important to note that sometimes we say that well, how as a small country can we have an impact on the planet? But in fact, Irish people per capita have a very high impact. If we all lived like an Irish person, we'd need 3.1 planets. So we do have an outsized footprint, and buildings and homes are particularly responsible for a lot of that footprint. And that's why we developed something that goes well beyond the building energy rating, called Home Performance Index certification for new homes. And this covers all of the different indicators that homes have an impact on our carbon lifestyles. It covers all of the indicators that associated with our homes. So if we are so this currently is only for new homes, but all of the same indicators can be applied to existing homes. So if you look at the building regulations and BER, it's only looking at energy efficiency of certain elements within the home, such as heating, hot water, and lighting. Whereas we're looking at everything from the carbon emissions associated to water efficiency, to daylight levels, acoustic comfort, embodied carbon, right through to biodiversity, and particularly things like connected location, how far you will have to travel, will you need to own a car if you live in that particular home, which has a massive carbon impact on our carbon footprint. So in terms of, there may not be an awful lot you can do about the connectivity of how well connected your home is, because over the next 8 years, we need to transition to the 15-minute city. And that means being able to get around by walking and cycling, and we all have to ditch the car. I don't think going to electric cars in urban areas is enough, because they create as many problems as they solve in terms of the space they take up. Because even if you have an electric car, it has to be parked somewhere. It requires 6 or 7 other car spaces elsewhere in order for you to be able to drive from your home to wherever you're going, and that in itself creates issues with flood resilience and biodiversity. So really, what we need to be getting to over the next 8 years is a 75% cut in car ownership within Dublin and its environs. And this is now possible. We have car sharing clubs that are available. I've given up my car over the past 3 years and saved a ton of money, enough to retrofit my home to a B2. So if you need a financial strategy to retrofit your home, that should be maybe where you think of starting. And then we mentioned already water efficiency. Water efficiency is something that's a little bit overlooked. In fact, as Susan Andrews showed earlier, it's responsible for 25%, about 25% of energy use in your home. So the simplest, cheapest way of dealing with that is to buy a €10 low flow shower head. And they're really well designed now. You'll get really good water pressure through that, but it'll be using a fraction of the water that you use. In fact, we've started a campaign to bathroom showrooms to really start communicating this. There is a water thing called the European Unified Water Label that gives a rating for each tap, for each shower head. Bathroom showrooms should be displaying this. We're doing a campaign to them now to get them to show this with every sanitary ware compliance, because this is probably one of the cheapest things you can do to cut your energy consumption. It'll cost you nothing, relatively speaking. The other part, we talked about one-stop shops. We talked about different ways of renovating your homes. Now, as we're aware, not everybody can afford to do a renovation in one go. And I suppose it's akin to what I've been doing with my home over the past couple of years, is doing it bit by bit. So one of the ways that this is where it makes sense for homeowners to hire an expert. Now, Susan Andrews mentioned that you can get a building energy rating advisory report, and that will give you a fairly generic plan for your home, but it's probably not sufficient for what most people need. What most people need is a fairly detailed plan of works for their home that looks at your home, because your home may have issues like water ingress, it may have structural issues, and they all have to be dealt with first. So what you really need is somebody who can come and have a look at your home, see what needs to be fixed first, and then set out a plan over the next 5 or 10 years, depending on how much money you have, that avoids lock-in, so you can carry out certain measures and then move on to the next measure without having to undo the previous measure. And I suppose this looks something like this. If you've got limited means and you can only carry out works a certain amount, spend a couple of thousand every year, this could look like this, and it's a fairly generic one. First thing you may look at is the ventilation, because ventilation, you have to get that right before you start making the house more airtight. So you could do that in the first year. Actually, the first step is to fix all the issues to do with leaking gutters, to fix any structural issues, to make sure that there's no underlying issues that need to be dealt with. And then you get into making sure there's an adequate ventilation system. Then perhaps you could, the second year, you could look at dealing with the roof. That can be done as a separate thing, so long as you work out how you're going to connect the roof insulation and the air tightness to the walls. And the third year, then you could look at doing the external walls. Now you will need to do windows and insulation together, because the windows need to be connected to the insulation if you're doing external insulation. So the first three measures here will have gotten your energy loads down low enough so that you will be able to fit a low carbon source of heat, such as a heat pump. Heat pumps won't work by just putting them into the house without the insulation reducing the heat demand. So you have to get all of those steps right first. So now you will be on a route to decarbonisation, because the electricity grid will decarbonise. So even if you don't do anything more, your house will slowly be less carbon intensive over the next few years. But by adding, say, solar panels, we can go a step further. Now we've got right down to a very low residual load, and we can now look at offsetting and getting to a net zero carbon, to really get into a net zero carbon retrofit. So, sorry, I didn't miss out on one particular slide. The one thing we also need to consider when we're carrying out a renovation is what is the impact of doing it? I know Mel Reynolds talked a little earlier about the impact of building very large houses. It's important to remember, if we are doing an extension at the same time as the renovation, every square metre of that renovation will typically take about half a tonne of carbon to build. So if we're building a 100 square metre extension onto our house, that's a 50 tonnes of carbon up front before it's even occupied. And we need to be aware of this, because there's no point adding a highly carbon intensive extension on, trying to seek in order to reduce our overall carbon consumption. So that's really important that we actually evaluate what we have already and see if we can, if that's enough. I mean, with my own house, I actually knocked down an extension because it was blocking the light into the main house. So I reduced the overall footprint of the house. And that also made it much easier to renovate, because I didn't have complicated add-ons that all needed to be insulated and would add to the cost. So this is something that we need to be aware of. And just a word on embodied carbon. Embodied carbon are all of the everything to do with the material extraction, the quarrying, the harvesting, the manufacturing of those materials, the distribution, the repairs that are required while your house is in use, and finally the waste management of the materials. So if you're looking at a low carbon renovation, you should be looking at the materials that you're using. You should be looking at the carbon footprint of those materials. Generally, kind of the PIR insulations, the EPS insulations will have a higher carbon footprint than the mineral wool insulations, but even better are bio-based insulations. Like Mel mentioned, the cellulose insulation is absolutely a rock bottom carbon footprint. Things like wood fiber, sheep's wool, all these are very low carbon footprint. So that's where I'm going to leave it. And thanks very much for your attention. I'll take any questions later.
Great. Thanks very much, Pat. As I said, yeah, if you have questions, if you could put them into the Q&A, and we'll get to as many as possible. And we're answering questions also in that. So our next speaker now is Mike O'Rourke from Electric Ireland Superhomes. So Mike is a senior retrofit engineer with Electric Ireland Superhomes and in the independent OneStop Shop service for energy upgrades in the residential sector. Mike studied in Dublin Institute of Technology and University College Dublin and has over 30 years of varied experience in building services engineering. For the last 16 years, he's specifically working in renewable energy and retrofit sector in Ireland, and has experience in the design and project management of retrofit installations and whole house energy retrofits across a whole variety of homes. I know he's been very active answering lots of questions as well. So thanks very much, and over to you now, Mike.
Good morning, everybody. How are you doing? I'm not going to get too deep into the technical side. Pat and Mel have both covered this very well this morning. I will touch on some areas. What I'm mainly going to look at is how you can benefit from the use of a one-stop shop to do your home energy upgrade. I'm assuming you can see the screen okay there at the moment. Let me know if not. So I'll quickly tell you.
Yeah, sorry, we're not seeing your screen. Are you
okay? Give me 1 second.
Yep, we can see it now. Thank you.
Okay, thanks. So I'll tell you very briefly who we are and where we came from. So Superhomes was set up by Tipperary Energy Agency and has been doing home energy upgrades since 2015, increasing on number as we went along. This year we went into a joint venture partnership with Electric Ireland to become Electric Ireland Superhomes. That gives us the ability and capacity to grow significantly in the number of houses that we plan to deliver over the coming years. So government targets, as mentioned by Susan earlier on, are to do 500,000 energy upgrades to homes in Ireland over the next 10 years. We plan to do at least 35,000 of those. So the one-stop shop model, basically, to try to capture it in a few words, what we endeavour to do for homeowners is take the hassle and the complexity out of it. But to do that, we need to take the hassle and complexity out of it for the contractors involved also. So we start at the beginning, we educate our clients, our homeowners, but also our contractors, and try and grow and develop the skill set in what is needed and how to do it. We take a look at every project individually, because particularly with retrofits or home energy upgrades to the existing housing stock, the housing stock in Ireland is quite varied. A terraced red brick house in Dublin is very different to a 5-bed dormer on a quarter-acre site in the middle of the countryside, and the measures required and the methodology in doing an energy upgrade to different types of projects requires very different types of approaches. Rather than being contractor-led, we are not the contractor. We are not the people who are doing the actual upgrade to your house. We're there to assist and advise you on how to get there best. And we do have a network of contractors and a growing network of contractors around the country that we can go to tender for. We can get prices from them for each individual project to try and get best value, as well as making sure that we get good quality on the project. We oversee the project right from the beginning, from the survey stage, specifying what measures make most sense for your home, and in setting out the tender, going to an appropriate contractor in order to make sure that we have the right contractor to fit the needs of your home and to give you the best result in the end. There is, with a complex project, there is a lot of, paperwork involved, checking certifications, making sure that the home meets the grant scheme requirements. So we deal with all of that, and we try and are constantly developing ways of helping homeowners finance these projects better as well, because they're not always going to be a low cost project. The costs can vary quite considerably from one house to another, depending on the level of measures required, but also the type of construction you're dealing with. So to give you an idea of, what we consider to be a super home, the current one-stop shop type grants that are available can provide grant aid towards the various measures. And we would always start, as Mel had pointed out and Pat touched on as well, we start with the approach of improving the energy efficiency of the building itself first before we start looking at technology that goes in to heat it and provide the energy that is needed. So that means insulating the house. So walls, roofs, floors in some cases, windows and doors, and getting the house itself more energy efficient. One thing that's often missed, and certainly looking at what others in the market are doing, they quite often, they will look at all of the insulation measures, but don't necessarily think about the air tightness and the ventilation side of it, which to our mind is absolutely crucial, but not necessary in a lot of cases to meet the grant scheme requirements. But to my mind, it's necessary from a technical point of view. It's necessary from a comfort point of view and an efficiency point of view. You can have, and I've come across a number of properties where a lot of insulation is added, but the house is left full of holes, air leaks. So the wind can just blow through them and you're losing a lot of your energy efficiency that way. So in a super home, we would always look to address the air tightness and look to address the ventilation to make sure there's always good quality air quality within the house to make it a comfortable and a healthy place to live, as well as addressing the insulation measures. Then from an energy point of view, another thing that differentiates us, I suppose, from a lot of others is that we do not do fossil fuels. We will always aim to get your house to a point where it is suitable to heat using renewable energy technology. In most cases, that's going to be a heat pump. In some cases, solar photovoltaic systems to generate electricity would be included as part of the project, but that's usually after we address everything else first. And if the homeowner then wants to do that as an option or an add-on, or if it's needed to meet the targets of the scheme. So the targets of these grant schemes is get the house to a B2. However, in the vast majority of cases, we find that once we've taken the logical steps of insulating the house, making it more airtight, adding in the mechanical ventilation and heating it with a heat pump, the majority of our houses end up better than a B2, usually B1, A3. We've even had a number of A2s and A1s in the end result. Just by default, by taking the right steps, we usually end up making that sort of an improvement anyway. So again, that's just an overshot of the, I suppose, insulating, air tightness, ventilation, heat pump, and in some cases, solar photovoltaic. Here you'll see at the bottom of this screen here, the houses that we're dealing with can generally be anything with a BER rating from C2 right down to a G. And in the projects, we will always be getting them to at least a B2, but more often than not, they're up at the A3 and B1 category by the time we're finished. So sorry, my slides are jumping ahead a little bit. So the journey or the steps that we would take a homeowner on when you start dealing with us as a one-stop shop, the first step is an initial consultation. That's usually set up with a video consultation or a telephone consultation to go through the basics of your house and try to get a sense of the type of house, the size of house, what work may have been done to improve the energy efficiency so far, what possibly remains to be done. And the main goal of that consultation is to get that broad sense of the type of house, but also to discuss with the homeowner what they are open to doing and what they're not open to doing. Not everybody is willing or in a position to do everything that might be ideal. So we try to find the right route to get them where they need to go, but in a way that makes sense. So by the end of the initial consultation, the homeowner will usually have a very broad and general idea of the amount of work that may be involved. They'll have an idea of the scale of cost involved. And at that point, both ourselves and the homeowner will be in a position to say, well, does it make sense to move on to the next step and carry out a detailed survey? If the homeowner decides to move to the survey stage, at that point, one of our retrofit engineers will visit the site. They'll measure up, they will do a detailed examination of all of the existing elements of the house, the walls, the floors, the roofs, the windows, the doors, get an idea of how airtight the house is or how leaky the house is. And by taking that information back and working on it, we can basically draw up the plan, the retrofit plan, as to what measures make sense in this house, starting with the lower cost, bigger impact type measures and moving down through the scale until we get to the house to the point where it meets the grant qualification criteria, where it's hitting at least that B2 level, and also adding in our recommendations of what you can do to make the house even better than that. When you get that energy report, you'll have a much more accurate idea of the cost of the project and of what we're proposing to do. We also manage the entire grant application and processing side of things. We secure a contractor for you, and we'll plan and schedule the work, and we will have oversight of that contractor on that project from start to finish. This kind of fits, I suppose, the model that Mel mentioned earlier on, where a homeowner is primarily looking at a project from an energy upgrade point of view. And it's not necessarily the bigger project where you're building an extension or there's a major refurbishment. However, we do handle those types of projects also. The main difference in that scenario here is in steps 2 or 3 here. In this case, we'll work together with your professionals, your engineering team, your architectural team, if you have those on board, to take a look at what they're planning to do and what they aim to do. And we'll review that and we'll offer our advice on how best to do what they aim to do, but whilst meeting the energy requirements of the schemes, but also for the best possible end result for the home. So there are different routes, but they're the 2 main routes where we're working with clients. One where it's a straightforward energy retrofit, and the other route where you have a design team or there's other major renovations or extensions happening as part of the project. So just to kind of give you a very quick, I suppose, case study of a pretty typical type project. So in Cormac Madden's house, it was a 1960s 4-bed house. He followed that typical model where we went through the steps, surveyed the house, drew up a detailed plan, and made recommendations as to what best suited his house. He started off a G rating, at a G BER rating. We carried out the insulation measures, air tightness measures, changes doors. In his house, his existing windows were sufficient and didn't need to be replaced or improved. We put in a heat pump for his primary space heating system, and he went for the option of also putting in some solar photovoltaic panels. And at the end of that project, he was at an A3 rating. It was a relatively straightforward project. I think total project duration for the contractor on site was about 3 to 4 weeks or less. So that just kind of gives you, I suppose, a rough overview of how we approach it. But what I would bring it back to is an energy retrofit on a house can be a very complex process with a lot of steps in it. And we're there to basically hold your hand through that and take the complexity away from you and give you the right independent professional advice to do that ideal home energy retrofit and give you a super home at the end of it. And another thing that Mel mentioned earlier on in his presentation was about the use of space and how I suppose some people look at just building on and building on. One comment that comes back to us quite regularly from Superhomes owners after they have done the project is that they find that whilst they haven't added space to the house, they suddenly find that they have more usable space, because previously they were putting a minimal amount of heat because of the expense. They were only heating the rooms that they needed to heat and only when they needed to heat them. But Superhomes owners tend to come back and say, well, now my whole house is comfortable all of the time. It feels like I've got a few extra rooms. So I'll
Great, thanks very much. Yeah, very good point, actually. None of those kind of cold no-go areas of the home. So our next speaker is Paul Durrant from the Dalkey Sustainable Energy Community. He's a member of the Tidy Towns SEC, and he applies his knowledge and experience from his long and varied career in terms of countering the climate change. He's a Bachelor of Science and Masters of Science, and has had various different roles in IT and media sectors, including Managing Director and Director of R&D in a company that was attached to University of Limerick and Trinity College Dublin. He was CEO of the Internet Providers Trade Association prior to retiring. So the Sustainable Energy Communities is a great initiative, and I noticed that we have a couple of questions in relation to people living in apartments. So where things are approached, not just from a single building perspective, but in terms of a whole group and trying to mobilize that. I think this is a great initiative, and yes, Paul will tell us more. Thank you.
Thanks, Evelyn. I'd also like to thank Open House and Laoghaire-Rathdown County Council for giving us the opportunity to tell you about our experiences in initiating a community-based initiative to reduce carbon footprint of our local area. Well, just to tell you about the journey that we had, this really started when just one member, almost by accident, Fiona Tracy, attended an environment information meeting, and at that she learned that future Tidy Towns competitions will be adjudicated more on the UN Sustainable Development Goals. So she brought these ideas back to Dalkey Tidy Towns Committee, and certainly in November 2018, it was agreed that certainly cleaning up the atmosphere was just as important as cleaning the streets and improving the aesthetics of our town. But the question was, what kind of projects could Dalkey Tidy Towns do in line with these UN goals? So this was researched quite a bit, and a number of options came up, but it was found one of the main things was that their SEAI was running this network of sustainable energy communities who are working on just such projects all over the country. And what's more is if we joined, we'd get a mentor free who'd help us get started and give us our direction. So the Dalkey Tidy Towns SEC was formally got underway in March of 2019. Very quickly, our mentor introduced us to the whole concept of an energy master plan, which is the basis on where we are now and the sort of things that we can do to get to where we want to be in the future. So the journey overall involved a lot of learning for us, grappling with concepts and technologies which are very much new to us. Unfortunately, we had to jump COVID hurdles as well and put in a lot of plain hard graft. But nevertheless, the work was completed on our EMP in April 2021 and was formally launched in June of 2021 by Minister Oisin Smith outside the Laoghaire, and he's the Green Party TD for our constituency. So to look a little bit about what you've got to do to get an EMP in place, we found very quickly that you had to meet certain conditions. SEAI don't just give out the money. You've got to put in a meaningful application. And these conditions were that you had to set up a steering committee. Now that was quite easy for Dalkey Tidy Towns because we had a group of like-minded people, and we had a team of 3 drawn from that to be the committee for looking after our sustainable energy community. We had to then create a community charter that basically lists out the aspirations of our community in terms of what we can do to save energy and what we want to achieve. And then we get into the nitty-gritty of actually applying for the grant. But that involves quite a bit of work of gathering information. We had to calculate an approximate current energy spend for our SEC area. Now, this was calculated in a very general way using CSO data and published SEAI assumptions. Along with this, we had to ensure that there were businesses who were prepared to put their names to development of our EMP. And then we had to look at the various challenges and opportunities that we may encounter in completing our energy plan. But what I mean by challenges, things like we don't have any very big industries in Dalkey area, so there's no sort of single big win in terms of energy saving. Anyway, we put all of this into the application. I'm glad to say we were successful. And this grant came through in October 2019, so we're able to actually get to work on producing our EMP. And just about doing an energy master plan for a community initiative is a huge part of it is that we have to get community buy-in. So community engagement, along with the technical detail of developing a plan, it's those two things brought together that really give you the whole of an energy master plan which is workable for the area. So what do we do to develop this energy master plan? Well, you know, we're volunteers, as you heard from the introduction. I'm not an energy professional, and nor are my teammates. So the very first challenge we encountered was that we had to identify and retain a suitably qualified and experienced energy consultant. We had to write the RFQ, the request for quotations, which was sent out to 6 SEAI approved consultants. Now, we were helped by our mentor in putting that together, but the mentor had to remain neutral when it came to who we selected. We were given a consultant evaluation sheet, and that allowed us to kind of tick against the boxes of what we thought was suitable of the 4 consultancy companies that actually did respond to us, and to let us select which one of those appeared to be best suited for us. Having gone through that process and having got a consultant on board, we set about the actual technical detail of developing our EMP. Now, I could talk for hours on this, but it's with the amount of time I have today, I'm just going to pick out some of the leading actions. Being primarily a residential suburb, the number one area, as we've heard already, for saving money is by reducing heat loss in homes and the very many small business premises that are in the Dalkey area. In doing this, as you can see from the milestones on the slide, we had to actually establish a baseline of energy usage. Now, this is not from the CSO data, but this is by actually examining the houses, doing very detailed energy audits of the businesses and building energy ratings for the houses. And we selected 10 typical housing types to do this. And so we could therefore have a baseline, and then we could examine the impact and cost of various energy saving actions that could be taken on these. From our perspective, the real thing as a team of 3 people working on this was that we found it was very much an interactive education process for the talk for our team. So turning now to the findings of the EMP, one of the things that, as contrary to popular belief about looking at Dalkey, it's not actually a place which it consists entirely of Victorian mansions and so on. In fact, the majority of houses in the area are very standard semi-Ds, terraced houses and apartments that were built in the range of 1946 to 1990. And these were not built with particularly good insulation in mind, so we discovered that there's actually widespread opportunities for retrofitting if homeowners are willing. Now, you can see on the slide here, what we did is that we took 10 types of houses that were typical of the area and did this very detailed rating on them. And then we put in all the various options that could be done on that house and costed those out with the aid of our consultant, so that people would know what things could be done for a particular type of house, what kind of cost was involved, what kind of energy savings there would be, and typically what kind of cost of period of return of investment would be. So we've got basically 10 typical house types, and people can look at these and say, yes, that looks like my house. I know what I can do on that. So from a community point of view, what we're aiming at is to meet the national targets, and that is to get 25% of the national housing stock retrofitted by the end of 2030. Taking that proportionately in Dalkey, that's the equivalent of us doing 750 retrofits in that period. So it's not just about insulation. We also found that there's opportunities on these houses to make gains by introducing renewable energy technologies of various types. So our goal then was to say, well, what kind of things could be done? Well, these additional things are things like heat pumps, solar panels that can produce electricity. By the way, our EMP also examines similar things for the service industry premises as well. Just want to say the EMP is just not about buildings. We've also examined the number 2 consumer of energy, that's transport, and we've also looked at the green energy generation opportunities there might be in the area. I'm not going to talk about these today, but just to say they're not ignored, and we certainly intend to use them in future projects. Now switching to engaging the community. This is hugely important. We wanted the community to know what we're about. So we organized a Save Energy at Home show in the local town hall. We had exhibitors promoting things like insulation options, EV chargers, electric bikes, solar panels, etc. We also wanted to engage all age groups in the show, from children to senior citizens. So in addition to talks which were given at the show by SEAI and by other energy experts, we also had a transition year student presenting on youth perspectives on energy conservation. To entice families along, we also ran, very cunningly, a children's art competition in the national schools. And we got 9 local businesses to sponsor prizes. We got local artists to judge the entries, and the winners were to be announced at the show. And of course, this caused the children to drag their parents in, kicking and screaming to see if the kids had won. But also it meant that the parents saw what was happening in the show, and hopefully whetted their appetite for maybe they could do something to improve the comfort of their homes, save money, and also contribute to saving on carbon going into the atmosphere. The other activities we've done is we've run a switch and save campaign to encourage local residents to review their energy bills and save money by swapping energy providers. And in addition, when swapping, try to choose a as a provider, I should say, that offers renewable energy sources so that you're actually saving on carbon dioxide there as well. We also ran things like how to save energy for our senior citizen, the Dalkey Ladies Club, and we continually write articles which are published in the community newsletter about energy saving and tips. We also promote these on our Facebook pages, and we run promotional activities such as posting tips and things in local shops and notice boards. A very important part of this whole process was a community survey, which we ran ourselves. The objectives were to engage people on their doorsteps, drum up community support, but also very importantly, gather the views on the current energy consumption behaviors that existed and find out the attitudes of people that they would have to actual change, such as how open they were to possibly changing to an electric car. Unfortunately, when we were all prepared, had all the survey worked out, COVID lockdowns hit, and we had to switch to a completely online version and also some hard copy versions that could be distributed. And we ended up with 100 survey responses. Now, that was very good in the circumstances, but unfortunately, it didn't get the statistical representation in some more unusual dwelling types that we would have wished for. And I'm sure the survey's impact would have been a lot greater had COVID not interfered. So turning to what were the benefits? Well, due to time constraints, I'm just going to focus on the domestic side of things. And we've calculated if people just do the average moderate level of retrofitting in their homes, if we get 750 homes done by 2030, it would be a fantastic achievement, but it would mean that there will be a reduction of about 4,200 tonnes annually of carbon emissions. And just to put this into perspective, to try and visualize what that is, that's the equivalent weight of 340 double-decker buses. So we're saving that weight in carbon dioxide being chucked up into the atmosphere just by the small area of our Dalkey SEC. And if some people choose more advanced measures, the reduction could be even greater. So what's the next stage? Well, the next stage is we have to get these retrofits going, and we can't do this ourselves. So we will be appointing a one-stop shop for our community actions. They'll, as has already been discussed, do all the work of applying for grants, managing, doing the project management and ensuring compliance. Just to say, the Energy Master Plan is not set in stone. It's an evolving document, and we will certainly look more at the transport opportunities and get projects going there, and other things such as microgeneration or community sharing of solar energy. Through this ongoing process, we would hope that we can drum up support in the community and get people actually partaking in these projects, and possibly even achieve a greater CO2 emission reduction for Dalkey in the end. So I hope you found this very brief and rapid overview of what we'll be doing on this community project helpful, and I'd be glad to answer any questions in the Q&A session. Thanks for your interest.
Great. Thanks a million, Paul. Sorry, I was just trying to find my mouse there for a second. Right, so our final speaker is Katie Harrington from Codema, which is Dublin Energy Agency. We work very closely with them and the 4 local authorities in Dublin too. So Katie just recently joined the team in July 2020, and she's the Energy and Climate Awareness Officer and the Communications Lead for the Sustainable Energy Communities. So as Paul just spoke about the Dalkey one, so people who are interested in that programme, she's also the contact for that throughout the Dublin Midwest region. So she holds a Bachelor of Science in Marketing from DIT and a postgraduate diploma in Digital Marketing, and is currently completing a Master's of Science in Climate Change in DCU. So I think the collective experience of all our speakers today is you know, very substantial, well into the hundreds, so or a couple of hundreds. So I said, Katie, if you want to take that, and then we are running a little over time, but we'll take questions at the end of this. And I said, I know a lot of your questions are being answered in the chat as well. So I said, yeah, Katie, over to you. Thanks.
Great stuff. Thanks, Evelyn. Hopefully everyone can hear me. But yeah, thank you so much for inviting me to speak this morning, and good morning, or I think at this point it's afternoon, everyone. Yeah, so for the next 10 minutes or so, I'm going to take you through kind of a whistle-stop tour of our award-winning home energy saving kits. So briefly, before I introduce you to the kits, just to quickly explain who Codema is and what we do. So we are Dublin's energy agency. So we were set up over 20 years ago, and we are a not-for-profit public good company limited by guarantee. So we work on behalf of the 4 Dublin local authorities, and our mission is to accelerate Dublin's low carbon transition through, innovative local level energy and climate change research, planning, engagement, and project delivery, really in order to mitigate the effects of climate change and improve the lives of citizens. So at Codema, we are firm believers that you don't have to be an engineer or have a technical background to understand the energy use of your home. So whether you're renting accommodation or you own a house, it is so important that you're comfortable in the place that you call home, especially even more so now that many of us have been working from home. So I wanted to include this pie chart just to give you an idea of the average energy use in an Irish home. So I won't go into detail because I know Susan referenced this as well, but I'm going to basically be taking you through our home energy saving kits, which can aid in identifying problem areas in the home in relation to these areas of space heating, hot water, electrical appliances, and then you can make improvements that will aid in the comfort of your home and reduce your energy use. Now, some of you may have heard about this scheme already, but there's probably a lot of you here this afternoon that don't know anything about it. So I'll start by giving you a little bit of background to the scheme and then explain what the home energy saving kit is and how it works. So just to give you some background, we launched this as a pilot scheme back in 2016. And at the time, the kits were only available in about 10 libraries in Dublin. And this was the first time a scheme like this had been introduced into Ireland. So we weren't sure how it was going to go, what the demand would be like, but thankfully it's been very successful. And the kits are now available to borrow from over 100 libraries across the country, including all of the Laoghaire-Rathdown libraries as well. And it works exactly the same way as borrowing a book from the library. You just go in with your library card and you can borrow a kit for 2 weeks or so. And then just to briefly touch on the why. So like many elements of our climate crisis today, energy is not very tangible. A lot of people only show interest in their energy usage really when their energy bills come in at the end of the month. So the Home Energy Saving Kit aims to tackle that home energy upgrades. A common piece of advice is to, get an idea of the current energy efficiency of your home and the energy that you're currently using and maybe wasting. And the Home Energy Saving Kit can really help with this first step. So the tools kind of have a dual function in making you firstly more aware of your home's energy use, and then secondly helping you to identify areas for improvement. So for example, your house may have walls that might need better insulation, or you might have electrical appliances that are really driving up your bills and so on. So it's not going to solve all energy issues overnight, but it is a stepping stone and an excellent starting point to allow people to initiate their awareness around energy usage in the home. So what is in the kit? So we have a thermal leak detector, a plug-in energy monitor, a temperature and humidity meter, a radiator key, a fridge freezer thermometer, and we also have a water flow rate exercise, and then of course the all-important user manual. So looking at our first tool, this is a thermal leak detector, and this tool allows you to measure the temperature of your walls, your floors, around your windows and doors, your ceiling and so on, to spot if you have any heat escaping or if you have any cold air drafts in your home. And it's a very easy tool to use. It uses an LED colored spotlight, which will change color when it picks up on a change in temperature. So for example, if your windows aren't sealed properly, it will switch from a green light to a blue light to show you that there's a cold air draft coming in. And then it will switch from a green light to a red light to show you that there's heat escaping in your home. So it's great for identifying areas in your home that need better draft proofing or more insulation and so on. And as you can see from the picture there on the screen, I used it in my converted home office and I found both drafts and thermal air leaks. So a bit of work to be done there. And the next tool in the kit is our temperature and humidity meter. And this will allow you to check if your home is at the ideal temperature, which is 18 to 20 degrees for occupied spaces like your kitchen and living room, and 15 to 18 degrees for places like your bedroom where you might not spend as much time during the day. And the ideal humidity level is 40 to 60%. Any higher than this, you may be experiencing problems with damp and mold. So it's really important to understand this and then rectify this straight away. And the next tool is our radiator key, which allows you to bleed radiators in the home if you have a wet central heating system. And basically it just releases any trapped air to make sure your heating system is working as efficiently as possible. And then our next tool is the plug-in energy monitor, and this allows you to measure the amount of electricity your appliances are using, from your kettle and your laptop to maybe your hairdryer and phone charger, and you can then work out how much each appliance is costing your household. And it's also a great way for identifying bad habits in the home. So for example, I recently did a test where I compared the amount of electricity that would be needed to boil a full kettle versus boiling enough water for just 1 cup of tea. And I calculated that by filling the kettle full every time we wanted a cup of tea in our house, would be adding about €50 to our energy bill at the end of the year. So you can imagine the savings you could make by testing this out around your home with other appliances. Then moving on to the fridge freezer thermometer that's in the kit. So very simply, this tool allows you to make sure your fridge and freezer are at the most efficient temperature setting. So that's 3 to 5 degrees for your fridge and -15 to -18 degrees for your freezer. Any colder than this, you could be using unnecessary energy to cool your fridge and freezer. And you just pop the thermometer into the fridge and freezer for 30 minutes. And if you find the temperature is not at the most efficient temperature setting, just adjust it using the dial inside your fridge. And then we do have one final exercise that you can carry out in the kit, and that's how to measure the flow rate of your water coming from your shower head and taps in your home. So an ideal flow rate is about 9 litres of water per minute. But in many houses, particularly with older houses, the flow rate can be as high as 18 to 22 litres a minute, which is not only wasting a lot of water, but it's wasting a lot of energy in heating up that water. So the exercise in the kit will allow you to measure the flow rate, and it also provides tips on how to rectify this, which I know Pat mentioned earlier, so such as purchasing low flow shower heads and aerated faucets for your taps. And there's also a step-by-step manual in the kit, which explains very easily how to use all of the tools in the kit. And all of these resources, including our guide to home energy savings, YouTube videos detailing how to use each tool, are all accessible through the link there on the screen, codema.ie/energy saving kit. And then this is just our map detailing where you can pick up a kit if you are interested in borrowing one. So they're available in 14 counties at the moment in 116 libraries. So you can find your closest kit by checking out our interactive map at codema.ie/energy saving kit. So before I finish up, just a few things I wanted to draw your attention to. Firstly, our Think Energy Hub. So you'll find our guide to home energy savings, which I just mentioned, and this guide has 94 tips on how to save energy at home, from free to low, medium and high cost measures. We also have tips for saving energy in your workplace and more tips for saving energy while working from home. So you'll find all of this at codema.ie/think-energy. And I am particularly going to plug a survey that we have just launched, which we want to get the public's views on how we can move Dublin away from fossil fuels and make our capital a clean and healthy county to live, study, work and visit. So we'd love to hear your thoughts. So we'll put the link in the chat. Alternatively, you can take down that URL on the screen there, and you'll also find it on our website at codema.ie. So thank you all so much for your attention. As I said, you can find all of the information I've shared this morning at codema.ie, and please do follow us on Twitter and Facebook at Energy Saving Kit and at Codema Dublin for updates and more energy saving resources. Thank you very much.
Great. Thanks, Katie. That's fantastic. And, you know, I realize for participants, I mean, it's a whistle-stop tour. And I mean, it's just fantastic having this range of expert speakers. I know there's lots of events that SEAI run and Codema as well. There's YouTube clips and everything. So we'll just take one or two questions and then wrap it up because we are over time. So I just wanted to mention as well that there was a motion at our county development plan meeting on Thursday that this planning authority will support and encourage buildings of innovative design which seek to achieve passive or net carbon zero design standards. So that's a very significant development. Now that will have to go out for final approval, but that motion was raised and was approved. So we're very hopeful in terms of future proofing of the county. And I know quite a few of the panelists have been answering questions in the Q&A, so we'll just take maybe one or two and then wrap up. So there was one about a few of the presenters have spoken about PV panels rather than solar water heating panels. What is the preferred energy efficient approach for water heating to be energy efficient? So I don't know, Mel or Susan, or who would like to take that question?
I can quickly go in on that there.
Thanks,
I think
Mel.
PV has overtaken solar water collectors, hot water collectors in popularity due to falling cost and also maintenance issues. I think a number of the manufacturers have quietly stopped producing the evacuated tubes for some of these systems as well. Certainly the Tim Cooper, who is involved in Cove Muse, has been monitoring the PV output on the Green Building for 26 years. And the output on that array, that's a photovoltaic array that was put in, I think it was Ireland's first one, has the same output today as the day it was installed. So there's been no diminution in output at all. The only maintenance required on PV was, I think, that those arrays were cleaned. And when he cleaned it, it was in 2 sections. He cleaned one section and measured the output in comparison to the one that was dirty, and the output was exactly the same. So I think the PV, the costs have dropped dramatically, even in 3 or 4 years. They're really robust. They've no maintenance really at all, and they're very, very popular. And it looks like the outputs are going up and the costs are going down further. So I think as a sort of really robust, simple, renewable, they're the ones to go for at the moment.
Okay, and just another quick question then, maybe Susan might take this one, or possibly Mike. Could someone speak about the amount of noise that is created by heat pumps and ventilation systems? Is there a way of seeing real life examples of this in use? So if maybe Susan or Mike wanted to take that.
Yeah, well, I'll give a quick answer, but I know Mike has answered in the chat, so he might come in on this as well. I know it does depend. You need to consider where you locate the equipment. So that's the main consideration when you are getting, the likes of heat pumps installed. Look at where you're putting the equipment. Mike, I don't know if you want to add to that.
Yeah, certainly. I mean, there's I suppose like a car, some cars can be a bit noisier than other cars. Some heat pumps can be noisier than other heat pumps. In general, modern heat pumps are relatively quiet, but you do still and should still think carefully about where they're located to minimize any possible impact. Certainly, you don't want, in an ideal world, be putting a heat pump, quiet and all as they are, in the dead of night. Even the smallest noises can be a little bit more detectable. So you don't ideally want to be putting that right outside a bedroom window, and certainly not facing a neighbor's bedroom window. So just locating the equipment, both from the point of view of getting ideal performance, but also from the point of view of minimizing any disturbance, is important. I'd say the same is true for ventilation fans. Again, most ventilation fans provided and installed correctly. In other words, in an ideal world, you would always look to mount them on anti-vibration mounts to further deaden the sound. But in locating them as well, if they have to be located in an attic space, you look to locate them over a non-occupied room, like a bathroom, rather than directly over the head of a bed in a bedroom. Because again, they're very quiet. It's like having a fridge running in your kitchen. Most of the time you don't notice it's running, and it's only when it switches off you suddenly notice a little bit of more silence in the dead of night. But it's thinking about where to put the equipment, installing it correctly, but generally this does not arise as a problem.
Okay, well, thank you very much. And I said, I know we've run over, so I just want to thank each of our panelists this morning. So Susan Andrews, Mel Reynolds, Pat Barry, Mike ORourke, Paul Durrant and Katie Harrington. And also then in support we had Suzanne Fitzpatrick from Codema, who hosted the Zoom event, and my colleague here, Vela Moshe, and our Energy Performance Officer, Andre Dargan, who has been a long champion of energy efficiency and climate action. So we thank you all. One of the participants today, and at one stage we peaked at 172 participants, so we're delighted with that, will be picked from the Zoom list, and we'll be in touch in relation to the €50 One for All voucher. And just to let you know that the recording of this event will be available on the DLR YouTube channel towards the end of next week. If there's particular slides you wanted, you can email us at energyteam@dlrcoco.ie. And thanks again, everybody, for participating today. Obviously, it was very interactive, and I said for all the panelists and everybody involved. And just to let you know that Open House Dublin is the architecture festival. There's a whole host of other events that are happening over the weekend. So if you go to openhousedublin.com, you can look at those events, including in our heritage houses, and we've an event up in Dean's Grange Library later today in terms of accessible equipment. So thanks again, and I'll wrap it up there. Bye now.